find out the maximum influence into bending moment, right? The maximum influence of bending moment. Okay? So I have asked you to solve the problem, right? So have you tried? Everyone has tried? Have you tried? Position you are getting maximum, right? Positive negative change is happening from 1 to 2 and 2 to 3. So 1 to 2 and 2 to 3. And there is a change in position where? Position number 2. So for position number 2, at 1. And for the load position 2, you must find out the value of bending moment. That part is missing. Maximum bending moment you have to find out for the position. We have done it. So ordinate positions you have found out. So this is the relation 3. This is load position 2. This is load position 2. Okay. This one. No, you haven't got. 263.25. Saurabh, have you answered? Have you done? Right? Why? What is the problem solving you are facing?
So that change in slope.
Huh? Change in slope. Change in slope for moment.
Yes.
So moment change in slope. He has done it. He has done it. See. Change in slope for moment when you will be doing. I'll show you another one short-term problem. Let's say how the diagram will come for it. Diagram will be looking something like this. Correct? So what you have to do? First thing, you see, first thing change in slope. So if you want to do change in slope, you will have to position your load first. So where the concentrated load will be positioned, it will be positioned first over the maximum ordinate point. So where is the maximum ordinate coming? Point C. So maximum ordinate will come over here. So point C, that is what? I am not concerned about values. Just see the procedure. So first position, what will happen? Your 4.5 kN load will come over here. Correct? Your 18 will be coming over here. Another 18 will be coming over here. Right? For the next position of the load, what will happen? In the next position of the load, this 4.5, this is 18, this is 18, right? So this 4.5 will come down this slope, right? So next position of the load is something like this. So 4.5 will come over here, correct? And your 18 now will come over here. So this here it will be 18, and next this 18 will be moving forward, and it will be coming over here. Simple, right? So what is happening? So first position, if I take this white load condition, first one. So that is giving you M1, correct? And second position is giving you M2. So if I do the change in the moment, so how much will be the change in the moment? Delta M 1 to 2, correct? So what you have to do? You have to first find out the slope of this straight line. So you find out slope of this straight line. Yes, sir. You know how to find out slope. You find out slope of this straight line because the slopes will be different. Correct? In this case, slopes will be different. Why? Because C is not positioned at the middle. C is 3 meters away from the right hand side. Correct? If C is positioned at the middle, left hand suppose, right? So if C is positioned at the middle, both the lines will be joined with the same slope. But as the two straight lines, if you see the equation of the straight line, when you find out the equivalent diagram, the equations will be different, and they will be having different slopes. So if the slopes are different, we will have to find out both the slopes, right? So found out S1, has found out S2, right? So what is happening to this 4.5 load? What is happening to this 4.5 kilonewton load? Can you explain? Gulab, you have solved it, right? You have solved the problem. So explain. So 4.5 kilonewton load, what is happening? So if I want to find out this delta M12, then what is happening to this 4.5 kilonewton load? See your copy and tell. You also tell. Into minus slope is how much? S2 is how much? 2.5. So slope, this one is coming down, right? This one is coming down. So this load is changing position from this to this, and it is coming down, right? So downwards, it is moving downward the slope. So it will have 2.5 minus. Next, how much distance is traveling? 1.5. Sit down. So 1.5. Have you understood? So this is the first one. What is happening to this second 18? So initially it was positioned over here. 18 was positioned. It has moved forward to this position. So 18, and it is rising up or down. So what is the slope? So how much? 0.83. Here it is coming 2.5. What is 7.5 by 3. It is 7. Not 7.5. 0.75. 0.75 by 3. This will be not 2.5. This will be 0.25. Isn't it? Anyone correct me? 0.25, right? Yes, 0.25. We have done 7.2.5. You also have done 4.5. So, it is not 7.5. It is 0.75. Yeah? 0.75. Why 7.5? 7.5 will come when you are having a 10 kilonewton load placed over there. Influence line is constructed for 1 unit, right? If it is for 10 kilonewton load, then you have to reduce it again. So that is why I think your movement value has come little bit more, right? So it will be not, that is what thinking, that it will not be 2.5, it is 0.25, right? How is it coming? This ordinate will be 0.75, right? This ordinate will be 0.75, and how much is this distance? 3. So S2 will be how much? 0.75 divided by 3. So 0.25, right? And this one will be 0.75 divided by 9. How much is it? 0.083. 0.083, right? Yesterday also same value was there. So this weighting is rising up the slope. So if it is rising up the slope, that means this much slope it is rising up. So 0.083. 3. Multiplied by how much distance it is traveling? 1.5 meters. Next one is which one? 18 into 0.083. Again this third load, right? Third load is rising up and it is coming to this position, right? So it will be 0.083 multiplied by 1.5. Have you understood? So this is how we will have to find out. So step by step we go forward. Okay? So we are clear? So who hasn't tried it? Who all have not tried? Aditya, have you tried? Huh? So could you find out the slope and could you find out delta M12? Mila hai? So you correct it. Then your value will be little bit lesser. Process is correct, but your influence line value, whatever you have got, that is not correct. It should be, you have multiplied it with 10. It should be for unit load of dimensionless quantity. Okay, unit load of dimensionless quantity. Amisha, have you tried? No. Why? See, I am repeatedly telling that if you are not trying, then you will not be able to solve the problem. उसका have you tried? हुआ? मिला है? आंसर मिला? अभी समझ में आया? Got it? you clear? Ankur, is it clear? Or still you are having doubt? All of you are clear? Okay. So you see, this is what is the process you have to follow. For same thing, what you have done it for shear force, same thing is being done for moment. Only in case of shear force, what was there? You just try to find out the understand the difference. So in case of shear force, you had this kind of impulse line diagram, right? So when the load was moving up this slope, there was a drop from this to this. So that is why there was a -1 multiplication with the load. Because there is a drop happening. After that it is rising up the slope. But in case of bending moment, you see there is no drop. But it is not that drop will not come. Drop will not come, it is not like that. Suppose I take a simple supported beam with overhang. Let's say I take a simple supported beam with overhang. There is overhang over here. So then you will see there may be some drop coming or rise coming. Okay, and there may be a zero value coming. Okay, so any time you want to find out the maximum influence either for shear or bending or slope or deflection, whatever it may be, do the change in slope method. What you have to do? You will have to first find out the slopes of the different straight lines. Okay, and multiply the slope with the value of the load and the changing position of the load. Correct? If there is a drop, then you just consider that drop, and from the positive to negative or negative to positive, you consider the sign also. If you do not consider the sign, your values will be wrong. So yesterday you had a question that why it is -1. So when you are considering drop, you will have to consider positive and negative values. So it was dropping from 0.75 to 0.25 over here. So it is dropping from positive 75 to 0.25 over here. So that's why it was coming negative. But when if you see, it is the case when the loads were moving from this side to this side. But if the loads were moving from this side to this side, then what will happen? Then there will be a rise. Okay? So there will be a rise. So this is what you must understand clearly.
Only considering the force which are varying linearly or any kind of force you can consider.
In influence line diagram, should I consider loads
Which are only linearly varying. So what we should
which are linearly varying? What do you mean by that? Linearly varying means?
These are the lines which have been shown the diagram. We say linear straight line, inclined straight line. Means the loads are varying. Means
Loads are not varying linearly.
constant loads are there.
It is not varying load. It is the moving load. We are not considering varying load. Loads are fixed, and those conditional fixed loads are moving over. That is what is happening. So loads are basically moving. It is not varying. And why? Every part of the influence line will become a straight line, because we have seen it through our understanding that the influence line diagram will consist of only straight line.
Only straight lines.
Okay, it cannot have any other thing. It will be all a straight line. Be it influence line for shear, be it influence line for moment. So whatever you do, it will be always for this thing. Okay. So have you understood? Okay. So now you see. Let us see. Actually, I have shared this with you to Canvas. Canvas who are logged in and seeing. So there is a discussion thread I have opened in Canvas. Okay. And in that you can see this presentation, total presentation I have uploaded, as well as I have given you my some handwritten solved dropped out problems also. Okay. So you see there is a problem for bending moment. It was handwritten worked out in that handout. Two sheets I have uploaded. Okay, in the discussion thread. So from the discussion thread you can download. Okay. So you see here you see this is what is the point C. The The beam is like the 40 meter length. The girder is 40 meter length. This side is 10 meter, this side is 30 meter. Okay. Now you will have to find out what is the maximum influence because of this 2 kilonewton, 4 kilonewton, 3 kilonewton load. Now you can understand here there is a little small difference between the previous load case. What is the previous load case? In previous load case also you see the loads were different. Loads were different, right? It was 4.5 kilonewton, then 18 kilonewton, 80 kilonewton. But they were separated by equal distance, right? Here you see there are 3 loads and loads are also different. You can see loads are also different. So there is a 2 kilonewton load at the head and then 4 kilonewton, then there is a 3 kilonewton. And they are separated by different distances. See, this is separated by 4 meter, this is separated by 6 meter. So here, through this problem, you will be able to understand where to position the load. Because the position of the load, you see, it will depend on how you are moving the load rather than how you are positioning the load, not how you are moving the load. So you will have to position the load and the concentrated load on the maximum coordinate position. Okay? So you see, if I am not getting into the influence line diagram construction, so you will be able to see here why we are getting straight line, correct? So this is how we do it. So for this portion to this portion, I will take it. So from 0 to 10 meter length, one bending moment influence line I will get. From 10 to 30 meter, one influence line, one influence line equation I will get. So with these two equations, I get this one. I get this one. Okay. This kind of diagram I will get. Okay. So now, if I get this kind of diagram, you see what is happening in this case. If I want to take this as my point, okay. So now you see. So this is coming 10. So it is 7.5. That's why it's coming 7.5. Yes. Okay. It's coming 7.5 over. So now you see, loads are moving from this side to this side. That means loads are moving from what? Right side to this is right, right? Right side to left side. So when it is moving, what will be the first position of the load? What will be the first position of the load? Who will tell? पीछे से कोई बोलिए. बोलो. Aditya will tell what will be the first position of the load? Huh? This is your influence line diagram. So where should be the first position of the load? On the maximum ordinate, I will place the first one. Huh? So what is the maximum ordinate? 7.5 is the maximum ordinate. So on this, I will be placing this 2 kilonewton load. First load is 2 kilonewton. So on this, I will be placing my first position. So 2 kilonewton load, and then 6 kilonewton, and then 3 kilonewton. Okay? And you see separated distances 4 meter, 6 meter. Correct? Now if I find out the slopes, so what will be the slope of this straight line and what will be the slope of this straight line? So it will be S1, if I take this one as S1, so this one as S1, so it is 7.5 divided by 30, so I am getting 0.25. If I do this one, so what will be my slope? It will be 7.5 divided by 10, I will get 0.75. So slopes are different. So slope of this straight line is this one, slope of this straight line is this one. Is it clear? Have you understood? Now I have to do it with change in slope method. So if I do with change in slope method, what should I do? So change in slope method. So first position of load. So let me go to mode and explain. So you see, so your influence line is this one, right? Influence sequence line is this one. Now, first position. So what is this load? How much? 2 kilonewton, right? So here you are having placing 2 kilonewton. Next one is 4 kilonewton, right? How much is the distance? 4 meter. Next is 3 kilonewton. How much is the distance? 6 meter, right? Clear? So what will be the next position? So this is my first position. What will be the next position? Exactly the same thing. Whatever you have done it. So what will be the next position? Next position will be. So I'll draw a separate diagram. Then it will be more clear. So let's say next position of load. So if I draw another one, this one equivalent line. So next position will be this load will be moving little down over here. So if I want to bring this load, please clearly understand this. This is very important. I am telling you. If I want to bring, so what will be my critical position? Next critical position will be what? My next load should be placed on the maximum ordinate position. So what is the next load behind 2 kilonewton? 4 kilonewton. So if I want to place the 4 kilonewton load on the maximum ordinate, how much should I move? I should move by 4 meter. Correct? I should move by 4 meter. Have you understood? So my condition here is how much should I move to bring my point load under the maximum ordinate position. That is what will give you the cases. You understand? That is what will give you the cases. So if I move this load by 4 meter distance, so what will happen? Then 4 kilonewton load will come over here. So next position of load, so this 4 kilonewton load will now come over here. And then if this load is moving by 4 meter, please try to understand. If this load is moving by 4 meter, how much this load will move? 4 meter. How much this load will move? 6 meter. Will it move by 6 meter or 4 meter? 4 meter. It will move by 4 meter only. This is what is the point you should understand. It cannot move 6 meter because it is attached to that load. So movement of the load, अरे बाबा गाड़ी का चक्का तो सोचो, सामने वाले चक्का अगर 4 मीटर आगे जाएगा तो पीछे वाले चक्का क्या 6 मीटर आगे चला जाएगा because it is attached to the axle. Will it happen? Yes or no? Then, so we are considering the middle load to move by 4 meter. So if the middle load moves by 4 meter, then the front load will also move by 4 meter, right? So front load is moving by 4 meter. That means this 2 kilonewton load will be coming somewhere over here, right? So here it will be 2 kilonewton. So here the distance will be 4 meter itself, right? However, this 6 kilonewton load, the 3 kilonewton load, this will be positioned at 6 meter distance only. The position will not be changing. It will be at 6 meter distance only. However, the movement of the load will be how much? Movement of the load will be 4 meter. That means, what I am saying, that means when it will be moving up this slope up movement will be 4 meter. So now if you see, if you try to see that, so you see, this is what is delta M12. So delta M12 will be how much? So delta M12, position number 1 is bottom, position number 2 is the upper one. So first one, 2 kilonewton load has moved the slope down, right? How much slope down it has moved? This much slope down it has moved, right? This much slope down here. So 4 feet, 2 kilonewton load. What is the slope of this one? This line was 0.75, and it is positive or negative? Negative slope. So negative slope means 2 multiplied by minus 0.75. How much distance it has traveled? x2 minus x1 is equal. Got it? Have you understood? Now what happens to the next load? Next load is 4 kilonewton, right? So 4 kilonewton load is moving up the slope. So how much up? 4 meter distance, and 0.25. Up slope, that is positive. 4 multiplied by 0.25, and what is this 4? This is x2 minus x2. Got it? So this is P, this is S, this is x2 minus x2. This is the formula you are using, right? Next, 3 kilonewton load. What will happen to 3 kilonewton load? See, maximum time you do mistake, you multiply this with 6. This is the mistake is being done. Because you see, when the 1.5 meter, that equidistance load we are studying, okay? At that time there was no confusion. But when the loads will be separated by different distance, the confusion will come. But one thing you should understand, that whenever there will be movement of the load, it is not that axle is moving or the position of the loads are changing. Position means two wheels are not coming close to each other. It cannot come. What is happening? The position of the load is changing depending on the front load movement. And the position you are considering depending on the case which will give you the maximum value when the concentrated load will be positioned at the maximum coordinate position. Is it clear? See, some of you are, I think, not at all listening. That is what is happening. You just behind you, who is there? Are you listening anything? Are you listening? Are you listening anything? What is your name, Arnav? Huh? Are you listening? What I was telling? See, that is why you are not understanding and you are not learning. That is the problem. What are you doing? You are writing something in your notebook, right? Sitting at the behind. You see, if you do not listen, then how do you perform? Have you understood what is the concept around you? No. And I think if I ask you whether you have tried the previous year's problem, you will say no. No sir, I have not done. Samne jo idhar aake baitho. There are a lot of space over here. Come. Have you written anything in your copy? Till now, what are you doing? Let me see. Have you written anything? So much thing we have discussed today's class. First problem we have solved. Second problem we are in between, almost finishing. You have not written and you have not scratched on your copy. So have you understood? Delta A12, have you got it? Clear? Now what will be the next position? So now I am coming. So this is my case number 2. So what will be my case number 3? Can anyone tell? So case number 3, let me draw it over here, right? Let me draw it over here. So what will be case number 3? 2 to 3. So if I want to move it to 2 to 3, so this is my case number 2, right? This is my case 2. And this is my case 3. So what will be my case number 3? Here if you can answer the question, then I will see, I will tell that your concentrated load concept, movement concept is completely clear. You will have to tell. How much movement of 2 kilonewton load will happen? Or how much movement, what is this load? What is the value of this load? This was 3 kilonewton, right? So next movement, case 3. Case 3 will be what is the position of the load? You tell me. Correct. So you see, it is not 4 meter. Why? Because you see, if this 3 kilonewton load now moves by 6 meter distance, this much distance, then only it will be positioned at the maximum ordinate. So movement depends on the load. And how do you place the load on the maximum ordinate? That is very important. Okay? So if my piche wala load, the behind load, is moving by 6 meter distance to be positioned over the maximum ordinate, then how much will be the movement of the front load? 6 मीटर होगा कि 4 मीटर होगा? It will be 6. If the back wheel is moving by 6 meter, front wheel needs to move by 6. So it's not dependent on the separation distance. Rather, it is the movement of the road and how do you position the load on top of the maximum on the maximum ordinate force. So I think if you understand this, then any set of load series you can solve with changing slope load. Okay? So now next position you have correctly said. So this was, I think this distance was 4 meter, right? And next 6 meter movement will happen. So total this distance is 10 meter we have taken. So that means this load will come over here. So now 2 kilonewton load will be placed over here. Next, how much is this? 4 kilonewton load. This will be separated by 4 meter only by. It will not be separated by anything else. Okay? And this will be coming over here. So this is my 3 kilonewton load, correct? And this 3 kilonewton load, so here the distance separation will be 6. And this is 4 plus 6 is 10 meter. Correct? Have you understood? Clear? So now you can find out very easily what is delta M. See, these problems I have uploaded in Canvas, okay? And in the discussion thread you can see. Are you seeing the Canvas?
Yes, sir.
Many of you have uploaded the assignments also, tutorials also I have seen. 22, 25, 27 students have already uploaded, I have seen. I have checked some assignments also yesterday. Okay, very good. I tell you that if you are doing it in a single copy, all the problems, all the tutorials, it will help you to see not only for this exam, it will help you throughout your career or throughout before you enter into something. Okay, so you can just go through structural analysis, just tutorial see it, if you see your conceptual understanding will come clear. So that is what I told you, that is why I told you that keep a separate copy for this tutorial series. Okay, I will take a submission for all the tutorial series. You don't think that I will not take a submission. Hard copies I will see. Okay, ऐसे नहीं होना चाहिए. फिर से बता रहे हैं कि आदित्य का इसको स्कैन करके दूसरा आदित्य में जमा कर दिया. अभी कौन सा आदित्य कौन है आप समझ लो. ठीक है? नहीं तो शुभम का कॉपी कोई शुभम तो करेगा नहीं स्ट्रक्चर एनालिसिस. शुभम को ट्रांसपोर्टेशन पड़ता है. ना? सिर्फ ट्रांसपोर्टेशन. ये है. अपलोड करो. ऐड हुआ है कैनवास में. Have you added yourself? Okay. Still I find yesterday I have checked. I think still 30 students are pending. 13 लोग अभी भी add नहीं हुए. So please add yourself. Okay? Because next one tutorial I will be giving it through Canvas only. I am not going to send it through emails and all. Okay? Next tutorial I will be giving through Canvas. So ये concept clear है भाई? So now delta M23 2 multiplied by I am not getting into it. So how much distance will be multiplied over here? 60. Have you understood? So with this I hope your bending moment concept, influence line for bending moment or series of concentrated load is clear. Clear? You can time more. What is the time now? 45. Just last problem for beam I will take. In the Friday's class, I will explain you about truss, influence line for truss, and we will conclude the session for influence line. Next week, your CA exam. After that, I will start with indeterminate structure. Okay? So indeterminate structure analysis, I am preparing the presentation and all. So I will explain indeterminate structure after your CA. Okay, and CA3 will be totally on this influence line diagram, completely on influence line diagram. Now, I will just explain you one problem. See, you have done it for only simple supported beam, simple supported beam, right? Now here there is a beam. So if you want to construct influence line diagram, let's say for a beam with overhang, you can expect similar questions from in the CA3 also. Similar type of question you can expect. So you see this problem, okay, and you check it out and work out at home. Okay, don't just see it, just work out at home. Then only you will be able to do it. Okay. So you see, what is happening to this kind of beam? What is this beam? This is a simple supported beam and it has the overhang, right? So this much portion is over. So it is a 4 meter, 4 meter, 4 meter beam. So 12 meter is the total length of the beam. Simple supported portion is 8 meter and there is a overhang of 4 meter. Okay? See, overhang can be on this side, overhang can be on this side also. Okay? So both way overhang beam is also possible, single way overhang beam is possible. Now, if you want to construct the influence line for bending moment or influence line for shear force at point C over here, and C is the middle position of the simple supported portion of the beam. So in that case, how do you find out? The method of finding out the influence line will remain same. It is not going to differ. So what you have to do first? You have to position a unit load. Where will you position it? You will position at a distance x. The unit load will be of dimensionless quantity. It will not have any dimension. Okay? So what I am doing? You put a unit load at a x distance. Now depending on this x distance, you find out reactions. RA and RB. Okay? How do you do it? Take moment about RB. You find out RA. Total load minus RA plus RB will give you the value of RB. Correct? So you find out RA and RB. Already you have found it out for simple supported cases. Right? Once you find out RA and RB, then you see you are going to have two cases. Okay? So you see one case will be from 0 to 4 meter plus or minus. Minus. Just left of and then beyond C, you have to go and you can go up to this or you can go up to this depending on your bending moment condition. Okay, so now you see the first condition for moment, I am not discussing shear. First condition of moment I am saying. Okay, so moment what will get? RA into 4 minus 1 into 4 minus 6. RA, this is your RA into 4 multiplied by minus 1 into 4 minus x. So this is your x. So 1 into, if I take moment about C, then 1 minus 1 into 4 minus x. So with this I will get one equation. What is this equation? For x is greater than equal to 0 and less than 4 and 4 minus, that means left of the sum. Correct or no? Now with this, what I will do? I will put x equal to 0, I will put x equal to 4 and I will put limiting value x equal to minus x equal to 4 minus, right? So if I put this, I am getting value of moment at x equal to 0, 0 and MC 2. So if I put 4 by 2, clear? So if I now start plotting it, how do I get? I get here it is 0 and it is a straight line. Why is it straight line? X by 2. You understand why it is straight line? So always you will get a equation of straight line. Okay. So x by 2 it is nothing but mx. So where m is equal to half. So you get a straight line like this, right? Now for the next condition, if I take any section over here, so I will change the position and I will take a section crossing the point C, just like we have done it for what? Bolo? For the bending moment in a typical simple supported beam. Okay? So if I change the position, then what will happen? I will get another one condition, right? So exactly the same way, you see there is no difference. However, you see what we are doing? MC equal to RA into 4. So I do RA into 4, and where this condition will be valid? This condition is valid beyond this x equal to 4. So x is greater than 4 and less or equal to 4. Up to this value. Clear? Now you put the limiting condition, you will get the value. So if I put, so you see at x equal to 8, if you place, you will get the value equal to 0. That means your bending moment diagram, influence line for BMD will be, influence line for bending moment will be having a straight line and it will be crossing a point on the axis of the beam where it will have the value and then it will go to a negative value because there is a overlap. So this negative portion you didn't have in case of simple subject. So that is what I was telling you, that in case of overhang beam, what may happen? You may have Here you are having a rising slope, and then here you can have a understood? So this is the typical overhang beam problem. How to find out the inclination. Okay. Next class we will discuss about truss. Inclination diagram of truss. So truss problem. Again I tell you, you have already solved truss problem. In case of influence line also, same thing will happen. Only thing with unit load we will have to find. Okay. So method of joints or method of what is called sections will be using and will be solving a truss problem. So in the Friday's class we will be concluding on influence line. So thank you.